across onto the rocks, causing erosion. So it's wind blowing the dust particles onto rocks causes erosion. And we'll see examples of that where you see pockmarked rock, or you can see how wind affects the formation of rocks. Here you can see the work of water coming through, so the wind also blowing water erodes. Here you can see that water actually picks away at the rocking outcrops, and in this case the people are representing the work of water, and that water erodes the rock. Like you'd think that water was just water and soft and the rocks are really hard, but actually the water can erode the rocks, and it's really important that you understand that connection. Here we have a V-shaped valley. A V-shaped valley is cut through rock by a river, and it's a sharp knife cutting, and the water keeps flowing through, and it cuts a shape like a V in a valley. And you go into a valley and you say, wow, these are very even sides going up, and they're quite straight, and it's a V shape. You'll say, it was a river that made this valley. Whereas this one, next one will come up in a minute. I'll tell you when it comes up. Can you see that this river has cut through these layers of rocks, and it just keep on cutting through. And sometimes you can see the layers of rock, but it was the river that has made this chasm here. If you've been to Grand Canyon, very good example of Colorado River cutting through the rock. The land itself keeps on being pushed up. We talked about what forces there are to push land up, and the river keeps cutting it through. The Indus Valley, the Indus River is another really good example of that. That, as I say, the top of Mount Everest used to be at beach level, and it's been pushed up and up and up, but the Indus Valley River keeps cutting it down, which is why there's now a beach at the top there. We saw an example of this in the film yesterday. Actually, a man climbed up one of these rocks and sat at the top of it. Well, how did they form? Well, this is just really hard rock that was in a lot of soft rock, and then all the soft rock got washed away by the water. It was eroded, and what was left was this column of really hard rock. And how do you get a big thing like that sitting on top? Well, it was just resting on it when all of this mud was around, and when the mud got taken away, we see that this is a column of rock that remains. We saw some examples of that. I think they're in America, those videos we saw yesterday. I think it's in there. This is exactly what happened, how they made the pyramids. They wanted to create the pyramids, so how do you get to the top of the pyramids? They don't have cranes back then. So they actually created the land. They built the land up. They built the land up, built it up, built it up, built it up around, and so that they could put things on top. And then they took away the land again. In this case, the land was sand. When water seeps into rock, it sits there, and then as it freezes, as the water freezes and turns into a solid, it keeps the rock together, but it's broken. And then as the water melts, the rocks fall apart. So the water goes into the rocks, all the cracks in the rocks, and then it freezes. And when it freezes, it's broken the rock. When the next time the water melts, we see that the work of the water, this case by this person, it's not really a person, it's just a story, shows us how ice can erode rocks. Here we have a frozen river, which we know as a glacier. And New Zealand's got some really good examples of glaciers, the Fox and the Franz Joseph, both of which have receded kilometres at a time at the moment. It's sad because temperatures are getting warmer, and you need cold temperatures to have frozen rivers. So this is a frozen river, and you can see that it's just melting a little bit here. But that shape there helps to understand how the river is formed. Can you see when you have hills and when you have valleys, the river is always at the bottom of the valley. The river helps create the valley, but also the water goes to the bottom. So that's why the water is always at the bottom of the valley. No point drawing a picture and putting the river halfway up. It's always at the bottom of the valley. Here we have a U-shaped valley. The U-shaped valley is formed by a glacier. It is so strong, it just carves out all of that area there. When you go to Fjordland and you go on a boat, in Fjordland, let's say this filled up with water again, and you might go on a boat here, and you notice that the walls are not flat heading out like that on a V shape, but go straight up and down. You know that that particular valley was formed by a glacier and creates a U-shaped valley. This picture here is probably not the best example, but there are examples of how water flows off the land and actually it evaporates. There are much better examples even within Montessori. This chart I'd probably show. In fact, this is a better example of it here. You can see that the rain falls on the land, the river collects up all the raindrops, takes it to the sea. The hot temperature of the sun helps to evaporate the water, which forms clouds. The clouds are blown over land and around, and you're very aware of that. Here is the river network of a North American continent. These are all of the rivers, and you can see all of the tributaries leading into the Mississippi down there. Lots and lots and lots and lots of rivers. And here are the main rivers, again in the North American state. And here are the main rivers of the world. We have to colour in all of these charts. I teased them a lot. I said, look, what country's in the middle? Isn't that significant? Often they put New Zealand to the edge, but it's nice when it comes in the middle. And you can see all the rivers. And let's find out where all the cities are. Oh, notice all the cities are either close to the sea or near on the river, especially the old, because that was a transport, it was used for food, it was used for cleaning, it was used for labour, it was used for trade. And then you recognise the puzzle maps. Puzzle maps don't, the puzzle maps that you're used to don't have a place in a primary classroom. They're not really useful. Pin maps do. Pin maps is the next generation. We're getting there, but really the puzzle maps are too. It's just puzzle, there's nothing to it.
Yeah.
Did you see them in your aura?
Yeah, we had both pin maps and puzzles, but pin maps were definitely
Much more cool.
Yeah.
Puzzle maps are really sort of like 3 to 6 to 8 puzzle maps, yeah? Pin maps are... Has anyone seen pin maps? Do you know what I'm talking about? Yes, you two have. I want to show you. So today was stories. I thought we just got a little day, we'll just do stories, and then tomorrow let's really get into all the subject areas, which is geography, geology, history, biology, chemistry, physics, da. But I seem to have been a bit thwarted in... Yes, better?
Yes.